Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and Redis. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab on the right side of your screen. Over on that right side of the screen, you'll see a couple other options, the first of which is the chat tab. I'd like you to start warming that up for me now. Let us know where you are joining us from. Throughout the program, I want to see you keep using that, so let us know whenever our speakers say something that really stands out to you. If you navigate over to that handouts tab, you'll see there are some resources that have been uploaded. So feel free to grab those. And the presentation slides are included there as well. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program. So our topic today is how to level up your relational database. And I'm joined by Prasanna Rajagopal, Principal Industry Solution Architect at Redis, and Bill Schoonmaker, Senior Solutions Architect at Redis. Prasanna, Bill, thank you both so much for being here. Prasanna, you want to go ahead and get this presentation kicked off?
Thank you, Cody. I'm grateful for your time today. I am Prasanna Rajagopal. In my role as an industry solutions architect, I focus on solving business challenges using Redis. I have over 22 years of experience in the software industry, having worked in various roles in software development, professional services, and technical pre-sales. It is my privilege to introduce my colleague, Bill Schoonmaker. He is a senior solutions architect at Redis. He has been with Redis for over 2 years. He comes with decades of experience in managing and working with large databases. Prior to his Redis career, he spent his time as a database administrator in many different verticals, including financial services, telecommunications, healthcare, and retail. Thank you for your time today, Bill. Thank you. These are exciting times for the software industry. Every major industry from financial services, retail, gaming, and healthcare is changing rapidly. More than ever, companies are looking to use data and writing applications to transform their business and drive better profitability and returns. The applications written in the past decade, from shopping apps to delivery apps, are fast, easy, and a joy to use. These apps may use NoSQL databases and real-time data platforms to deliver an excellent customer experience. But older organizations still have many legacy applications that rely on slow relational databases. These organizations need help to modernize their applications to provide new and engaging services. Here are the topics Bill and I will cover today. I will start with the business needs and how relational databases pose challenges to meeting those needs. I will cover the importance of real-time data in today's applications and give you an overview of Redis Enterprise. After that, Bill will cover caching patterns, the Redis data integration tool, and Redis JSON. Bill is going to show you an exciting demo of Redis JSON and Redis Search. After Bill covers these topics and his demo, I will share some customer examples and point you to resources where you can try Redis Enterprise for free today. The best companies in the world understand that a great customer experience drives profits. When you deliver a great customer experience, you increase customer engagement. You reduce customer churn. Nobody ever says, I love my banking app and the service my bank provide, but now I'm going to switch my bank. Nobody ever says, I love my retail store or my e-commerce store. They have great products, excellent shopping experiences, great customer service, and good prices, but I'm going to shop at a different store. When you deliver an extraordinary experience, you get a customer for life. You reduce customer churn. When you minimize churn, you do not have to spend money on advertising and marketing to acquire new customers. When you do not spend money on acquiring new customers and your existing customers spend more, your profits increase. When your revenue goes up, but costs go down, your profits and margins go up. Relational databases were not designed to deliver modern-day customer experiences. You have to model data in a tabular format in relational databases. The tabular form may not be the ideal way how developers think about data modeling and does not meet today's application requirements. If your application requirements change, relational databases are difficult to change since they adhere to a strict schema. Relational databases were designed to store data safely. They were not designed for performance and scale. Many companies are looking at ways to modernize their legacy applications by either rewriting them or improving their scale and performance using a modern data platform such as Redis. You love your delivery app. These apps are very accurate in estimating delivery times. How do you think they do that? They accurately estimate using analytics, machine learning models, and an essential ingredient, real-time data. If you want to deliver a great customer experience, you need real-time data. You need real-time data in fantasy sports and gaming to drive player engagement. Powering the product catalog and product search feature in retail, you need real-time data platform for that. There are numerous use cases in financial services that depend on real-time data. Payment platforms depend on real-time data to complete complex money transfer operations. Many payment platforms use Redis to drive their real-time services. Stock trading, mobile banking, and risk management rely on real-time data to drive a fabulous customer experience. In many ways, Redis is the perfect in-memory data platform to drive this real-time era. It is built on open source, is best-in-class technology, and easy to use, deploy, and maintain. The open source version of Redis is the most downloaded database in the world. By any measure, Redis is a very popular database. Redis has a very engaged community of developers. The product is easy to use. It took me just 2 hours to write a sample app using Redis as the database using Python API. Redis Stack extends Redis open source with modern data models and capabilities. We have bundled together the best of the technology that we have to offer into an easy-to-use package. Redis Stack extends the core capabilities of Redis open source and provides complete developer experience for debugging and more. In addition to all of the features of Redis open source, Redis Stack supports probabilistic data structures, JSON documents, time series data models, and graph data models with support for Cypher query language. Simply put, Redis Stack is the best starting point for working with Redis. You can move from Redis open source to Redis Stack to Redis Enterprise and then to the cloud. We offer you flexibility in deployment models. Redis Enterprise is available on all 3 popular clouds. Redis Enterprise is a first-party native Azure service. Now you can access all the Redis Enterprise features and modules, capabilities such as Redis JSON and Redis Search and others in Azure Cache for Redis Enterprise. Microsoft fully manages Azure Cache for Redis Enterprise with a 5.9 SLA. Redis Enterprise is also available on GCP and AWS Marketplace. These deployments on GCP and AWS are fully managed with 5.9 availability as well. Redis Enterprise is built on Redis open source database and has all the features of Redis open source, plus offers features that companies need to deploy Redis in production, such as clustering, linear scalability, and 5.9 availability. For example, customers can deploy Redis Enterprise in an active-active architecture. Active-active is a data resiliency architecture that distributes the database over multiple data centers via independent and geographically distributed clusters and nodes. Yes, Redis Enterprise offers the reliability and high availability features that companies need. The feature that gets me most excited is the multi-model database support. You can create search indexes on your data using Redis Search and have super fast query and search feature in your application. If you need to store JSON documents, we offer Redis JSON. In short, you can cover all your application requirements using Redis Enterprise. You don't have to use multiple databases and deal with all the complexity that comes with that. Now, I will hand you over to Bill, who will discuss caching patterns, Redis JSON, and show you a demo. Take it away, Bill. Thank you.
Thanks so much, Prasanna. I appreciate that great intro. Today, I'm going to talk to you about Redis and specifically caching patterns. And I want to spend some time talking about the JSON module that is a part of Redis Enterprise as well, and also in Redis Stack. So first, let's talk about caching patterns and why they're important. As Prasanna mentioned, most of your data today, or a lot of your data today, is stored in relational databases. I used to be a DBA for financial industries for many years, and folks would come to us and ask us for data. They wanted it exported or extracted into various formats and various other data systems, and that took time. And with real-time data requirements that we have today, it's become necessary to take data from other places and get it into a system that's very fast to access. And that system that we're talking about today is Redis. So the first caching pattern that we're going to talk about is the cache aside pattern. And this is implementing Redis as kind of a first place to look for your data. So when we're dealing with Redis data, we're talking about sub-millisecond access times. Basically, it means that your data is going to come back very fast. And back to when I was a DBA, I used to strive for 10 milliseconds, 15 milliseconds, 20 milliseconds. And the more complex the query got, the more complex the stored procedure got, the longer it took to retrieve that data. And while I was retrieving that data, I was possibly impacting the writes that were occurring in the database. So I had to be constantly aware of the kind of give and take of the different applications that were requesting resources from my different databases. So if we apply Redis as a middle target for data ingestion or data retrieval, we can have that sub-millisecond access time. We can have the higher availability. We can have the durability that we need to ensure that it's there. So this particular pattern here is just putting Redis in front of your application. Your application will look inside Redis, determine if the data that you need is there, and if not, it'll still make that call to the backend database. Now, there's a bunch of different things that you can do to kind of make this work better, right? One is you can use data expiration in Redis. So if you know your source data changes on a regular basis, you can set a TTL, a time to live, on a specific key inside Redis. And when it expires, it simply won't be there for the next API call. And then it'll go back to the backend database and refresh your cache. Some customers who have less frequently changing data will just load their data on a regular basis, like maybe every 12 hours or every day or something like that. But the bottom line is your data is available in Redis for your applications to retrieve very quickly. Let's move on to the next pattern. So in these two patterns, the right behind and right through, we're actually implementing something called Redis Gears. And Redis Gears is implemented as a module, and we'll talk about modules in a little bit more detail in a few moments. But basically, this gear is responsible for asynchronously writing to the backend database, synchronously or asynchronously writing, or rather, when something changes in Redis. So as an example, if your application is dealing with retail information or say inventory, the write would be done to Redis and the customer would receive an immediate response that that item's been placed into their cart. And as a secondary transaction or as an included transaction, you would then update the backend database for persistent and longer term storage. And there's all kinds of things that'll be advantageous about that pattern, right? You could have your business analytics and your reporting reading directly from that backend database that you're persisting to, or you could have them even go into a replica of the Redis database that's stored somewhere else using a replica technology such as replica of that's built into Redis, or active-active, as we talked about earlier. This can do many things. It can improve your latency. It'll improve your efficiency of your code. It works in all kinds of use cases. Let's move on to the next pattern. So the read replica pattern, which I touched on briefly prior to this, is essentially creating copies of your Redis database, with which to serve other customers. So if your business needs another copy of that data for reporting, or if you need some geographical copy of that, you can create read replicas of the data. And as the data changes, it moves around wherever it needs to be for the geographical request that's coming in. So as you can see, these patterns are going to enable powerful features with which to enhance your current databases. But there's other things that we can talk about in terms of using Redis for microservice design. So as we begin to think about how we're going to integrate Redis into our data patterns and what that exactly means, we want to know what kind of tooling we have available. So in this example, we have a tool called Redis Data Integration that is available today that will incorporate a Debezium server, which has plugins to allow connections to backend databases. Now, you're wondering, how can I relate a table-based structure into Redis? How is that actually going to work? What structures would I use? And I want to point out specifically, there are lots of structures in Redis. There are things like hashes, there are strings, JSON, as Prasanna mentioned. But the two that we're going to dial into specifically for relational database ingestion are hashes and JSON documents. In the case of a hash data type, it is essentially a key of keys. So you'll have an ID that you'll reference the key as, and then inside that hash structure, you'll have many other flat-laced key value pairs. And so essentially, a hash key can be representative of a row in a relational database table. So if you have something like a product table or an employee table, and you have product ID 1 or employee ID 1, that would equate to exactly one hash key with as many fields as you want to include. This Redis data integration product has the capability to monitor backend databases. In the case of relational databases, it typically does that through a logging mechanism to minimize intrusion on the source database system. So you're not actually reading directly from the tables. You're usually using a logging mechanism or a redo log mechanism with which to read. So when you're monitoring a table, as in those employee tables or product tables, and some sort of a CRUD operation happens, a create, an update, or delete, something will occur in Redis. In this case, a hash record will be created, or a hash key will be created, or a JSON document could be created. In the case of JSON documents, they have the capability to have nesting. So you can create complex documents from more complex queries, things like materialized views or multi-table selects. Redis Data Integrator runs as its own JVM, and it has Redis Enterprise components built into it, where there will be a configuration database, and also uses Redis gears and Redis streams with which to populate the target Redis database. So if you're considering how you might get data from a source system into Redis, Redis data integration is a great way to consider doing that. So let's talk a little bit about JSON and how that actually works in Redis. Redis Enterprise has the capability to incorporate what we refer to as modules. We also refer to them sometimes as capabilities. And those modules enable different data types inside Redis Enterprise. So when you create a database in Redis Enterprise, you will choose which modules you want to include in that database. So if your microservice, as an example, needs a graph inside a Redis database, you'll simply enable that module when you're creating the database. So if you remember back to your knowledge of polyglot persistence, which means use the database that makes the most sense for the service that you're writing, this can easily become, the answer is Redis, because we can now say, I can use Redis as a JSON document store, I could use Redis as a graph database, I can use Redis as a time series database. All of these things are enabled through the power of modules. And we're not stopping there. There's the possibility of new modules on the horizon as well. If you're curious about them, though, I'm going to do a demo shortly that'll show you Redis Stack, which is a developer-centric version of Redis that includes all of the modules and can easily be stood up locally, or you can use our cloud managed service to quickly stand up a Redis stack. So this real-time data that we're talking about, we have lots and lots of data coming in from lots and lots of places. And the three V's of data, the volume, velocity, and variety, mean that we have to process this data in different ways, at different speeds, at different times, and different services to get it to where it ultimately needs to go. And this data all contributes to that customer-centric experience that we're trying to create to maintain those relationships and maintain those customers to ultimately help increase our profitability. So how do we do that, and why does JSON help us? Well, JSON, as you know, is a schemaless data type. And so that means that we're not set into rigid schemas, whereas as a DBA, I would have to write scripts to maintain and manage tables if there was some change going in for an application and a table needed a new column. I had to have all these considerations on how would that impact the current application processes that are running? How is that going to impact reporting? Am I going to break things that might be doing a select star from somewhere? Those kinds of things all have to be considered. In the case of JSON, the data simply comes in as a new element, and from key to key in JSON or JSON document to JSON document, the perfection and the perfect schema doesn't have to exist. Those things can change as they need to. So how that fast, flexible database, right? How do we do that? How do we do that in Redis? Well, again, we enable this module that will enable JSON as a key. And JSON as a key in Redis, as you might imagine, with Redis being all stored in memory, can be recovered and retrieved very, very quickly. The Redis JSON 2.0 is the answer, the powerful real-time document store that you're looking for to power your applications today. So we support atomic updates, we have full text searching, native index and querying, and we can deploy all of that with up to 5 nines of availability. And those 5 nines, as Prasanna mentioned earlier, can be accomplished with what's called geo-replication or active-active database. And what that means is that a cluster will be deployed, 2 clusters will be deployed in 2 regions, or one cluster in each region. And then each cluster has self-repairing capabilities, self-healing capabilities. So within a cluster, you'll have up to 4 nines of availability. And then when you add the second cluster or tertiary, 4th, 5th, whatever you might want, the data itself is synchronized across databases with what's called CRDTs. Those are conflict-free resolution data types. Essentially what they do is they just clear out race conditions. So each endpoint in Redis is readable and writable. So it differs wildly from what you may be used to in a replica of scenario, where that second copy or third copy, while it's usable, you can only read from it. It's kind of a game changer. We have lots of customers that are looking at it now, and some customers that even have more or less edicts that are coming down from above that are saying everything going forward has to be active-active. So as a cloud native, active-active type of solution for your database needs, your data modeling needs, Redis Enterprise is a fantastic solution for that. So these atomic updates that happen in JSON, where we're looking at a nested document, in just a moment, I'm going to pull up a tool called Redis Insight that will enable us to take a look at the data inside Redis. You'll be able to install that after this webinar, and you'll be able to use it with either a cloud-based database or a localized Redis database. But basically, we're not doing anything crazy here. It's all standard JSON. And in Redis, as you may or may not know, everything that you put in Redis is binary safe. So it makes sense that you can use this for your most intensive JSON database operations that you have. You'll have speed, you'll have flexibility, and you'll have that search criteria. And people have been storing JSON for a while in Redis, and they've typically used strings to do that. And the main advantage from going away from that is that you no longer have to deserialize and serialize your JSON as it comes in and out of your database, and you'll be able to work with it much more efficiently. Most of the clients have support. Most of the major clients have support for Redis JSON now. So whatever you're coding in, you'll find a client that will be helpful for your application. So native index querying and full text search, as we spoke of earlier. So these indexes are also implemented as keys in Redis through a module, another module called Redis Search. And Redis Search is implementing indexing as keys, as everything in Redis is implemented as keys. In the case of a Redis Search index, it keeps track of the things that you're asking for, either hashes or JSON documents, and essentially stores a live index that's kept up to date for keys in the database that meet the criteria of the index. So this will allow you to do all sorts of interesting things with Redis data and get to that data much faster than you normally would, which would be by iterating and scanning keys and determining if they contain certain values. So our usage patterns for JSON, three primary that we'll talk about here, starting from the left side as a query accelerator. So if you're using JSON today in strings and you're searching across that JSON, you're still getting some advantages from the speed of Redis. But taking that same data and converting it into the JSON module type, and then also implementing indexing with Redis Search on top of that, those two are a powerful combination to help you enable real-time data to your applications. We also have customers that are using Redis JSON for front-end database, where the data is duplicated in Redis and then stored to the back-end database as it changes in Redis. So your application is only dealing with Redis on a primary basis. And then when things change, those changes will be propagated to the back-end database. It allows you to still maintain that back-end database, again, for those other operations that may be occurring in the back end, but you'll have that real-time data on the front end for applications. And then finally, Redis as a primary database. And this is the one where folks will usually stop and go, wait a second, Redis is in memory, right? How am I going to use Redis as a primary database? What am I going to do for persistence? What am I going to do for durability? What am I going to do for availability? And this is where Redis Enterprise is going to really help you shine. It's going to help you come into your meeting and look at your boss or whatever and say, hey, this is the solution we need to get our data faster to our customers and to be able to really improve our availability and our accessibility to the data for our customers. And the way you're going to do that is through Redis Enterprise clustering. And the clustering capabilities of Redis Enterprise are going to enable all those enterprise type features, everything from high availability with intercluster replication to geo replication across active clusters, all the way down to governance and compliance with service level agreements on who can access what data, down to the granularity of specific keys. All of that is built in with ACL's access control list and role-based access control list. And then, as we mentioned, those client libraries, there's a client library for just about everything you could imagine. Most of the higher end client libraries will support Redis JSON and Redis Search. They'll have the functionality built in. And then we also have these object mappers for Java, for Python, for Spring and .NET, which will help you to map your existing data from your source databases into Redis. All right, so I am going to stop here and I'm going to bring up a demo. So hopefully you should see Redis Insight now.
Yes.
Prasanna, we got that?
I can see it. I can see it, Bill. Thank you.
Excellent. Thank you. All right. So what we're looking at here is Redis Insight. And Redis Insight is a free tool provided by Redis, the company. And Redis Insight is an IDE, an interactive development environment that you may or may not be aware of. There'll be links to download it in the available handouts. And it will allow you to connect to a plethora of Redis databases, including Redis Enterprise. And what I'm going to show you today is connectivity to a local Redis stack database that I have running on my Mac. So it's something that you can easily do. Another option for an easy deployment of Redis Enterprise would be using our managed cloud service. So there's a link to that as well. And I believe we also have a coupon available to access that, to get some free time to use that. But you'll be able to stand up a Redis stack, which will include all of the modules that we've talked about today and more. So the first thing I'm going to do is click Add Redis Database. And because my database is local, I'm just going to use my localhost IP and the default port of 6379. And I'm just going to click the Add button. Database has been added. And I'm going to click into this database. And right now you'll see I have no keys at all in my database. So it's a completely empty database. Couple of things to note on this screen. Hopefully it's large enough for everyone to see. But I have transactions that are occurring, which, it's flatline right now. There's nothing going on. How much memory I'm using right now, how many keys are in the database, how many connections I might have, and then some details about the stack that I'm running and the versions of the specific modules that I'm using. Down here, we have an easy entry into a CLI. So, if I want to quickly set a key, I can use that to do to set a key name that is named name and has a value of Bill. And then if I return to the browser and refresh, you'll see that I have a key named name with a value of Bill. And then I can even delete that key from here if I like, or edit that key as well. So functionally from the IDE, if we scroll down to either the workbench section or, let's go to the workbench section, and then we'll go to the Redis stack tutorial and the working with JSON section. And so these tutorials that are built into Redis stack, into Redis Insight rather, will allow you to understand and learn more about the different data types. So each one of the data types has a workbench guide. Document-based talks about hashes and JSON. Graph, of course, talks about working with graphs. And then we have time series. Vector similarity search, which is an addition to Redis search capability. That's a very unique feature that we have now. So vector similarity search enables things like customer sentiment data analysis, where you're looking at large volumes of data and you're trying to make some determination about that bulk data. So you shape the data in a way that allows you to get results back from it. We have customers today that are using it for large amounts of survey-based data, as an example. So if you have an application in the App Store and you have thousands of reviews, can you create some actionable items out of that with vector similarity search? And the answer is yes. So let's scroll back down here to working with JSON. So the first thing we're going to do is we're just going to create a simple JSON document, and we're just going to create a bike. And this is a simulation or an example of what a bike store might look like. So as we work down these different options, we're going to see how that might look in Redis. So you can see I've quickly added that bike and the data is now in. So if I go back up to keys again and I hit refresh, you'll see that I now have a JSON document set with keys in it, and I have that bike key that has been successfully added. Let's return to our workbench, and we will do a query to look for specific fields. So this first one, I just want to get the model, and the second one, I want to see the materials. And you'll see the result set here represented in tabular format, where for bike number 1, I retrieved the material, and bike number 2, or bike number 1, I retrieved the model as well. So very simple queries here. Let's get a little bit more complicated. So what if I wanted to update one particular thing and I want to change the model name inside a JSON document? Well, with this JSON.set, I can refer specifically to the model and I can update its value. And then if I get the specific field again, you'll see that the model has been updated to Hyperion 1. So let's load in a bunch more bikes, right? This is going to dump about, I think it's about 100 more bikes in here. Shouldn't take too long. This is all running locally again, so it's a Redis singleton process running on my Mac. So once that's complete, which it's done now, we will now look at our query browser and refresh, and we will see that we have 100 keys in our database, still only using about a meg of total memory. Our CPU has increased a little bit, and we also have a list here of all of the bikes that we've added. So let's go back to our workbench. And now we're going to create an index, which is where the fun starts. So this particular index is going to essentially create a schema on all of these fields, and it will call out the type of data that we're indexing. So in this case, text, numeric, tags, we want to be able to search by a specific value. These text fields, we're going to be able to search with any piece of the text that's in the field. We'll create that quickly. Now, what I want you to know here is that this index has now been created and has quickly indexed all of the existing data in the database. If I were to add another 100 bikes or 1,000 bikes or 1,000,000 bikes, that index would be kept up to date with the data as it changes in place. And then beyond that, there's a number of queries that we can execute once that index is created. We can now use the ft search command to begin talking about or begin querying on that data and understanding what's actually in there. So how many bikes did we return from this search where we searched by, we want them to be e-bikes. So in this case, we returned, I think, 6 values. And then we can search by category. So I'm not going to go through all of these right now, but I want you to understand how easy it is to stand up both Redis Stack and Redis Insight locally on your machine or in the managed service that will quickly enable you to work with all of these data types and all of these workbenches. Beyond this, we have aggregation, and the aggregation that can occur is begins to look a little bit like SQL, which is nice. So if you're familiar with SQL queries, some of this will look familiar to you. But in a sense, we can aggregate by bike types. We'll scroll back up and we'll see. We have 13 mountain bikes, 11 kid bikes, et cetera, et cetera. So that is my quick demo on JSON. I'm going to flip back to the slides and talk a little bit about performance of Redis Enterprise. And Redis Enterprise is always a clustered deployment. So in a Redis Enterprise cluster, we'll have a minimum of 3 nodes. And those 3 nodes can have any number of shards on them to build out databases. In this particular example, we used 40 AWS instances and were able to achieve 200 million ops per second at pretty close to linear scalability, which essentially means that if we would have gone to 80 instances, we would have been close to 400 million. We just stopped the test. But this just goes to show that Redis Enterprise is scalable. You can scale the individual nodes up or scale out with additional nodes. And then, of course, this shows active-active, but more importantly, it shows the potential for hybrid cloud and hybrid deployment options. All right. I'm going to pass it back to you now, Prasanna. Thank you so much.
Bill, a great demo. You know, the interesting thing about what he showed, the ease with which we can use some of these data structures, Redis JSON, with search, fascinating stuff. That's what gets me most excited about Redis Enterprise. And the other aspect that I noticed was the last slide that you talked about. So you are essentially able to replicate data in an active-active between different clouds and also in an hybrid fashion. Is that correct?
Yeah, that's correct.
Okay.
We would do that by having a Redis Enterprise cluster in each of those deployment areas. So you would have a Redis Enterprise cluster on-prem, an EC2, a cluster of EC2s in AWS, a cluster of compute nodes in GCP, a cluster of compute nodes in Azure, and then you would link all of those up as an active-active deployment, each of them readable and writable, and all of the data is synchronized automatically with no application code.
That's amazing, and it gives you flexibility to deploy your applications anywhere in any cloud, and that is a game changer, because sometimes we get stuck with one cloud and we have done a lot of development in it. The data all resides there. That's another thing that is really exciting stuff. Thank you for sharing that, Bill. Great demo. Thank you for walking us through that. I'm going to highlight a few use cases and a customer stories. You know, we talked a lot about Redis JSON, and let me move on to the next one. So Redis JSON coupled with Redis search, as Bill showed us so elegantly, is really one of the most fascinating things that I get to encounter and work with every single day. This opens up a wide range of use cases for our customers. Bill pointed to some of them. He did talk about some of those. I think he mentioned product catalog. Product catalog can be stored in JSON and then indexed and queried using Redis search. We can store user profiles. By the way, user profiles is one of the most popular use cases for Redis overall. We see financial services companies, retail companies, payments providers, all use Redis for that super fast access to user profiles for authentication and for other purposes. We also see many financial services companies use us for fraud prevention and fraud detection use cases. Redis Enterprise is popular as a high performance and scalable user profile and session store. We find massive stores in gaming, retail, and financial services. For fraud detection use cases, we use location profiles can be stored within Redis, and then location can be tracked for fraud detection purposes or for any other purposes like for geo search, for example. With capabilities of Redis Enterprise, the possibilities are just endless. So let me share a couple of use cases here. This travel intermediary customer helps airlines sell ancillary products such as seat selection or baggage. So when you go to a website, a travel website, and you're trying to book a flight, then airlines want you to prepay for baggage and prepay for a seat selection. These are high profit margin products. If they can sell it upfront, then that is a good product, good source of revenue for the company. The airlines would allow the numerous travel websites to market these products at the time of ticket sales and generate that incremental revenue, which generates these high profit margins. This agent, this is our customer, they couldn't scale their operations because they had to go back to the airlines and fetch all the data, the latest data. And for all these services, seat selection, you need to be tracking seat selections. So they need to be able to get the data in. It was proving to be giving them very poor customer experience. They decided to cache the data in Redis Enterprise rather than making calls to the airline backend database. Redis Enterprise helped them scale their operations seamlessly and deliver a great experience for the travel website who are their customers, who are the direct customers. This improvement in performance and scalability helped the travel website sell more seat selection and prepaid baggage services and generate extra income for everybody in this chain of business. My Team 11 is a leading fantasy sports company in India. It has over 17 million users. Many millions of fantasy users create and edit their teams in the last 30 minutes before the start of a game. The relational database could not handle the load during these peak times. They needed a solution fast. They started with Redis open source to see if Redis would fit their needs. Once satisfied with the open source version, they switched to Redis Enterprise to get enterprise features such as high availability and failover capabilities. Now they use Redis Enterprise as their primary database and have expanded the use cases beyond just managing teams to use Redis for user authentication and as a profile store. My Team 11 saw great business benefits and cost reduction by moving to Redis Enterprise Cloud on AWS. They slashed the use of the relational database and thus saved money on licensing costs. The Redis YouTube channel has an interview with the R&D lead at My Team 11. He has discussed their stack and has showed us how they solved their performance challenges. Many banks and financial services, like I mentioned before, globally use Redis Enterprise for their payments app. This is one of the most popular uses of Redis. On the Redis YouTube channel again, you will find an excellent presentation by the architect of the payments application at Capital One Bank. Capital One uses Redis Enterprise as its data platform across multiple microservices. Here is an example of a bank in India that struggled to scale their payments application, which was running on a relational database. They have millions of customers accessing the payments app daily, and the app's performance was not conducive to delivering a great customer experience. They moved their user profile, session management, and other critical data into Redis Enterprise. Let's have a few words about the total cost of ownership for Redis. People tend to believe that Redis is extremely expensive as it runs on data in DRAM. This is not true. For real-time use cases, when database needs to process thousands of operations per second, Redis is cheaper than any other database in the market, as Redis can efficiently perform over 25,000 operations per second on a single core. In large data sets, our Redis on flash technology, that's another interesting technology that we offer, allows Redis to extend DRAM with SSDs, making Redis Enterprise more attractive than any other in-memory or disk-based solutions in the market. The same goes for small data sets. Using our built-in multi-tenant technology, users can deploy multiple databases or caches at desirable prices. You have ideas in you that you can implement today. Try Redis for free. As Bill mentioned, you can try it today. Implement your use cases using various capabilities. Bill talked about Redis JSON. He also talked about Ashes. There are so many ways to do that with Redis, and that's the most exciting thing. And see which features would meet your requirements. You get $200 in cloud credits when you sign up today. You have a unique opportunity to make a difference. I hope you will use this opportunity to try out Redis Enterprise for your benefit. So thank you, and we are open to any questions. Bill, can you talk about the Redis data integration tool and the databases that it supports, please?
Yeah, so today we have support for Oracle, Postgres, SQL Server, and MySQL.
Okay.
And so those connectors that I mentioned, that product Debezium, which is an integral component of Redis Data Integrator, it has a number of connectors to look into backend database systems, not just RDBMSs, even some others. And so as we work through the most customer, the demand from customers are driving what we work on first. And so right now, those are the kind of the four primary platforms, and we're working to add more all the time.
Okay, that's good to know. Can you talk about the hybrid deployment? If you have any customers that they are using hybrid deployment, can you talk about that and the?
Yeah, so the most important thing to know about hybrid deployments, I think, is that if your company has a cloud journey today, like if you're looking at migrating apps and migrating data to the cloud, either as a cost savings measure or an implementation of extending your on-prem data center, what customers are doing are creating clusters on-prem and then creating an additional cluster in the cloud of their choice, or clouds, as we mentioned, and then enabling active-active. And so a very unique feature of Redis Enterprise as a multi-tenant database option, which means that you're not limited to one database on a cluster. So if you stand up a Redis cluster, that 3-node cluster inside your data center on-prem, you can create one database that is active-active to a second cluster in the cloud, and then have other databases on that same on-prem cluster that only serve apps on-prem. And then you can do the same on the other side. You can create databases in the cluster in the cloud that only support apps that are in the cloud. So, you've got both places with which that are read-writable for those active-active databases, and the ones that you don't need active-active for, you just don't create them in that configuration. So every database can have a distinct configuration on that cluster. And as your needs increase, you simply scale the cluster. You can either scale the individual nodes up, add more RAM, add more processors if they're VMs, or you can scale out and just bring additional nodes into the cluster. So all of those make for very easy transitions and extending to the cloud for our customers.
Okay, thank you, Bill. And can you speak to the managed services themselves? We briefly touched upon the Azure Cache, and can you speak to that, please?
Sure. So with the free Redis Cloud offer that's on the screen here, you will go to redis.com and you'll end up at a website where you can create what's called a subscription. And the subscription is essentially a cluster. And you choose where you want that cluster to live, i.e., which cloud, well, and then which region, and then even down to the availability zones that you want to employ for things like nines of availability. So you can actually create your cluster where it spans availability zones to make it less likely that the loss of an availability zone will result in the loss of a cluster or your data. So all in the name of constantly providing that fast access to data. So, as customers become more used to fast results, right? And things like how fast can I get an Uber? How fast can I validate a credit card transaction? How fast can I look up the restaurant nearest to me? We get used to that level of availability, right? That low latency response, and in order to keep that going, Redis Enterprise helps tremendously with all of these different deployment options that we're talking about. So you've got AWS, you've got GCP, and then you have Azure Cache, which is a slightly different animal here in that Azure Cache for Redis is Microsoft's basic service for Redis. And then we have Azure Cache for Redis Enterprise and Azure Cache for Redis Enterprise on Flash, which you briefly touched on, that are available right there in the same marketplace area that Azure Cache for Redis is located.
Oh, perfect. So, this Redis on Flash, we didn't cover that in this. We briefly touched upon that. Can you maybe highlight that I see, I have heard of customers, I have worked with customers, I've listened to their stories about how they use Redis Flash to reduce their overall cost, still having very good performance. Can you talk about Redis on Flash, please?
Absolutely. So Redis on Flash is a data tiering option. We refer to it as data tiering, where you will create that same cluster and that same Redis Enterprise cluster, and then expand the memory by using really, really fast SSDs like NVMe type drives. And you'll pick a ratio of how you want your data to be stored. How much data do you want in RAM? How much data do you want on Flash? And it works for a number of use cases. You kind of have to look at your data access patterns and things like that. And so if you have kind of a hot set of data, it's typically a good reason to use Redis Flash, because you can take smaller nodes and make them look like make them house a larger Redis data set. So if you think like a 20 to 80% ratio, you could take a 100 gig of RAM cluster and probably do a 500 or 600 gig Redis database on that same cluster. So infrastructure savings are really the primary motivator of something like that. And it's very useful technology. I have lots of customers that are doing multi-terabyte databases in that world.
So it's a great benefit in terms of delivering great performance using SSDs while at the same time saving on infrastructure costs.
Right. So looks like we might have one question from the chat.
Yeah.
I see 2 terabyte my PS database is equal to 2 terabytes or 2.5 terabytes in memory Redis DB. If I'm understanding that correctly, your question is, does 2 terabytes in some other database equate directly to 2 terabytes in Redis? It's kind of a multi-tiered answer. The first answer would be it depends on the data type that you're using, right? Some databases have overhead, particularly if I'm looking at relational database systems. When you look at the data set size, there's overhead associated with that. So it may not equate directly 2 terabytes to 2 terabytes. The second part of that equation is around replication. Like, do you want that data set replicated? So if it is truly a 2 terabyte data set and you want it protected, i.e. durable, then I would recommend as a solution architect for you to replicate it and see use 4 terabytes of space to store 2 terabytes, because you'll have exactly one replica in Redis Enterprise, which is an interesting differentiator between OSS and Enterprise. But I think that discussion is for another day.
Yeah, and also we have seen, like, you're well aware of this since you work with a lot of enterprise customers, Bill. We have seen customers who start off maybe, hey, let's start with user profiles, or let's start with the session store, and then they see the benefit of Redis. So these are fairly small data sets, and then they start, once they become comfortable with the Redis Enterprise and the clustering and the failover capabilities, then they expand it, and now you are growing with it. And that is, I hear that from many of our customers, how they started off small and then saw the benefit and continued growing.
So one of the advantages of Redis Enterprise with multi-tenancy is the capability to begin thinking of Redis as a service. And so, almost like if you think of your data center as having a large Redis cluster, and then as your businesses come and ask you for Redis as a database, you say, sure, I can provide that. And you're not standing up additional clusters, so you're saving some money from an infrastructure standpoint, and you're able to just scale that cluster as needed to meet the needs of the various business units that want to consume Redis.
Oh, excellent point. I mean, yeah, that Redis as a service, and and thank you for pointing that out. Thank you for pointing that out. And can you talk? You briefly touched upon Redis gears, and can you briefly maybe describe that in more detail? And also, I want to talk about Redis, some of the data structures in Redis that could help us become a Redis, like a message broker type use cases. Address message broker type use cases, please.
So the first part of your question with Gears is that, as I said, Gears is implemented as a module for Redis Enterprise, and Gears enables 2 types of processing, essentially. One is batch processing, and the other is event-driven processing. And the events can be either internal or external. So as an example, think about a specific key or range of keys that their values change. You could generate an event, so to speak, off of that type of a change and cause Redis gears to do something. And this is specifically how we enable some of those patterns we spoke of, where internally, if a key changes in Redis, like some application has updated a key, a hash, maybe a key value pair in a hash, then that may trigger ultimately an update to a backend RDBMS that has the same key ID in a table structure that's known to Redis gears. So that flow is really what we're talking about with gears. And also for doing batch loads of data. So let's say a CSV file drops into an S3 bucket, as an example. Redis gears could kind of wake up when that file shows up and produce a bunch of data inside Redis. Like maybe it creates a bunch of keys out of 1 million hash or 1 million CSV rows, common delimited rows.
Nice.
So that kind of explains gears. Secondary to that, your kind of your messaging services. So there's 2 primary messaging features within Redis and Redis Enterprise. One is the pub sub mechanism, which has been around for a while, where you publish a message and then any subscribers that are listening for that message will act upon it. They'll do something with that message. It's great. People have been using it forever. But the problem is that if you have no subscribers, it's kind of like screaming in the woods, right? If nobody's around, they don't hear your message. So there's no real logging. That message just kind of goes away. And for some cases, that's okay. But a lot of times now, people are really kind of avid about making sure everything's logged, making sure everything's audited. And so with streams, Redis streams, we now have an immutable object, an immutable log of these events that can be maintained and trimmed as necessary. And then we have what's called consumer groups that will read off of these streams and do something with that data. So I like to point to it in terms of data prioritization, which is one of my favorite stories today, is that if you think about the velocity and the variety of data that's coming in and the volume, how do you process all that noise, right? Well, streams is a fantastic way of doing that because it allows you to kind of put different data on different streams and have different apps pulling from those streams based on their priority.
Oh, amazing stuff. Fascinating. This is what gets me most excited is you can cover so many use cases with Redis Enterprise. Thank you for that. I think we are running out of time. Cody, back to you, sir.
Well, Bill and Prasanna, thank you both so much for joining me today. I know we filled all 60 minutes with information today, so I'm sure our audience really appreciates everything that you brought to the table. So thank you both so much for being here.
You're welcome. Thank you for having us.
So I'd like to remind our audience that this session was recorded. You will be receiving an email with a link to access the recording on demand, or of course, you can find it living on the DevOps website at devops.com/webinars. The 4 winners of our $25 Amazon gift card drawing are George L., Jim S., Akshat H., and Cheryl A. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card, but if you don't happen to see an email in the next 48 hours, do check your spam folder. I'd like to thank Redis for sponsoring today's program, and to our audience, thank you so much for spending your last hour with us. We really appreciate your time, and we really appreciate your feedback. So there will be a survey that will pop up on your screen as soon as we close out. Tell us what you liked about our program, or maybe what you'd like to see on an upcoming program. Otherwise, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And Bill, Prasanna, thank you once more.
Thank you.
Thank you.